everyone, my name is Izzy, and thanks for joining us for our first meeting of the spring 2022 semester, Intro to Python, presented by our president, Joshua Lazaro. If you're not a member of ACM-W, please scan the QR code to join. Membership is free. We have lots of giveaways, internship opportunities, and free swag. If you're already a member, go ahead and scan that QR code to sign in so you can get those attendance points. I'll give you all a few seconds to scan that. We do have some upcoming meetings this month. On February 7th, ACM will be having their first Intro to Tech workshop on the semester, so be sure to attend. On February 9th, we'll be having our ACM open house at the Rotama from 12 to 1, so come meet some officers and get to know some more about ACM. On February 18th, ACM-W will be having a social with the Biomedical Engineering Society at the Denman Ballroom from 4 to 5:30, so we hope to see y'all there. Are you interested in becoming a junior officer? Scan this QR code for more information for this great opportunity to get some leadership experience. It's a really good resume builder, and the best part is no experience is required. Don't forget, ICPC is hosting their second meeting this Saturday, so come join and learn how to nail those tech interviews with some great people. And without further ado, I'm going to pass it to our presenter, Josh.
Hello, good afternoon, y'all. My name is Joshua Lazaro, and I'm this year's president for ACM-W. First of all, I just want to say thank you to Izzy for that great introduction. So before we do get started, I do notice that we have quite a few students already in here. So if you can go down in the chat and tell us what your major is, that'd be really cool. All right. So aside from this, before I do get started with today's presentation, I will be sharing a Google Doc. In this Google Doc, we will be going over some code that I will be using later on in today's meeting. So awesome. So cool. We have a lot of comp-sci majors. That's really cool to see. Alrighty. So first of all, you all might be wondering, what exactly is programming? So whenever you turn on your phone to check the time or respond to a text message or to like a friend's picture, you're experiencing the result of what someone programmed your phone to do. Programming is a process of converting ideas into instructions that a computer can execute and understand. These instructions are specific and sequential. You can think of it a bit kind of like a recipe. Let's say you wanted to bake a cake. You would first need a list of ingredients and then a set of instructions. For our ingredients, we have flour, sugar, eggs, milk, and so forth. If you've ever baked a cake, you know that the amount of each ingredient can dramatically affect the outcome. If you accidentally use a full cup of milk instead of a half cup, then you'd have a runny mess on your hands. Or what if you swapped the baking soda for salt? The cake would never rise. In a similar way, the instructions we provide to computers needs to be specific so that we can get our desired result. So computers are very literal. They try to execute our commands exactly as you stated. So when we give them bad instructions, we might introduce bugs or even make the computer crash. In programming, a bug is when something unexpected happens, whereas a crash is when your program stops early or freezes, just like if you were to use the wrong ingredients in your cake. The order of the steps will impact your final product. If we mix the baking soda in before the eggs, we can cause our cake to be dense, or adding the milk with the butter may cause the dry ingredients to clump and leave us with a lumpy cake. So order matters. The same thing can be said about programming. It's all about giving computers the right instructions so we can get the desired results. This is important because programming is just as important as finding the errors and preventing crashes as it is about writing the instructions or code that a computer needs to understand. So to recap, programming is how we communicate with the digital world. It is characterized by having instructions that are specific and sequential. And when we get the code right, just like in a recipe, the end result is a program that helps us enjoy a little bit more from our world. So what exactly is a programming language? When you want to provide instructions to a computer, you use what's called a programming language. There are hundreds, if not thousands, of programming languages available, each made up of its own syntax or rules and semantics or meaning. Let me give you an analogy. So in English, we would write welcome and use an exclamation mark. But in Spanish, we would write bienvenido. Semantically, they mean the same thing, but Spanish, unlike English, requires an exclamation mark at the beginning and end of a sentence. This is one rule or syntax of the Spanish language. Likewise, programming languages also have unique syntax rules. So let's look at a few examples from the Hello World program. Maybe you've already heard of this program before, and it's the most basic program used for decades to get started with a new programming language. It helps to highlight the differences in syntax between languages. So this is how we would get to display Hello World when run using C++. Now, this may look strange to you, but that's okay. Soon you'll be able to understand exactly what's happening. So for now, I just want you to look at the syntax used in this specific language. This consists of double quotes around the words Hello World, and the use of a semicolon at the end of the statement. And there's a return keyword right before a closing curly brace. All of these things are part of the syntax or rules of the C++ programming language. Let's look at a few more examples. This language over here is called JavaScript. It's a very popular language used virtually in every website these days. This is how we would display Hello World using JavaScript. Notice the use of different syntax. First, the words Hello World are now inside of single quotes. We don't have any curly braces, and instead we see something about document right. And finally, here's Hello World in Python. It has a similar syntax to JavaScript, but now we don't see any parentheses, and the use of double quotes has a return just as how we saw with C++. Now, you may be wondering, what's the point of having so many different languages, especially if they all do the same thing? Why not just have one programming language and we all use it? Well, the main reason why we have so many languages is that each comes with its own set of strengths and weaknesses. Some are ideal for programming small devices with limited memory, whereas others were made to handle complex mathematical computations. Regardless of the language you choose, ultimately that language has to be broken down into the only one that computers can understand, which is machine code, or machine language. Machine language is computer language consisting of binary or hexadecimal, and it's extremely complex for us to write directly because it's mostly just a series of numbers. So as you can see here, we have a bunch of zeros and one, and this is what we call binary. Professor Mike Dehan compared machine code to DNA molecules. Can you imagine trying to read a DNA sequence atom by atom? That would take you forever. And this is why we have these other languages, Python, SAS, R, C++, Java, that we call high-level languages. They're closer to human languages comprised of keywords, structures, and syntax that's easier for us to learn and understand. So now you might be wondering, why Python? Now, Python isn't sponsoring us today, but one, it is easy to learn and use. When Guido van Rossum was creating Python in the 1980s, he made sure to design it to be a general purpose language. And as a result, the Python language is one of the most available languages, which gives us an emphasis on natural language, making it easy to learn and use. Python was created over 30 years ago, which has given it a lot of time for the community of programming language to grow and mature adequately to support developers. There's plenty of documentation, guides, and video tutorials for Python available at just a few clicks. Lastly, Python is accessible in many varieties of environments such as mobile apps, desktop apps, web development, hardware programming, and more. The reliability, efficiency, versatility, and speed make Python attractive due to its various usages. Now, let's go over some basic statements and expressions. Statements are the building blocks of any program and are the individual actions that you want your computer to take. Without statements, there's no program. Each statement can be made up of keywords, expressions, and operators. We'll talk more about keywords later. For now, we'll focus on expressions and operators. Operators are symbols that tell the computer to perform an action with some input. And the good news is that you're already familiar with many of the operators that are used in programming from your primary school education. So the plus symbol is used for addition, the minus is for subtraction, an asterisk or star to represent multiplication, and finally a / for division. These are known as arithmetic operators as they take numbers from their input and perform an arithmetic operation. So flashback to primary school. When we have 3 plus 2, the plus sign is the operator, and the 3 and 2 are the input, also known as operands. In programming, the combination of operators and operands that break down to a single value is called an expression. So let's look at a few examples. If we take the following 10 plus 2, what would that equal to? Now, if you said 12, that is correct. 10 plus 2 is our expression, and the 12 is what our expression evaluated to. Now, let's look at this other expression where the answer may surprise you. 2 plus 3 times 6. What do you think this expression would equal to? Now, if you said 20, you're correct. But if you thought 30, that's understandable. But in programming, the default order of operations is the same as in mathematics. The plus or addition operator in our example is evaluated after the asterisk or multiplication operator. That's why we get 20 instead of 30. So you may have been taught the phrase, "Please excuse my dear Aunt Sally," as a way of remembering the order of operation, or PEMDAS. That stands for P parentheses first, E exponents, MD for multiplication and division from left to right, and finally AS, addition and subtraction from left to right. It's important to keep the order of operations in mind, as your program could behave unexpectedly based on how these expressions are evaluated. So if we go back to our last expression, it evaluated to 20 because of the order of operations. But what if we as a programmer wanted it to process the addition first? In that case, we would add in the parentheses around our addition operation, and then we would get the result that we wanted, 30. So computer programs are made up of statements that can perform a mathematical calculation, display something to the screen, or even make a choice between 2 code paths. As we continue to explore the fundamentals of programming, you'll see how powerful this concept really is. So now let's go over variables and data types. Writing code typically involves the handling of information. So if we were making a game, we need to store the user's score. If we're creating a banking application, we'll need to have the current bank balance and so forth. We've already seen a few variables in the course so far, but now we're going to go into more detail about how they work and what they do. A variable is simply a container for a value, and when we run our program, the computer gives space in its memory when we can put the data that we want to use as a reference for later. This data is called a variable. Now, much like how we label jars in the kitchen so we know where to go for our favorite cookies, we declare variables in Python by giving them a name and then setting their value. This is called assigning the value. And this assignment is done with the assignment operator, which is the equal sign. And as we see here, age is the name of our variable, and because of the equal sign, we're assigning it the value of 20. This means that somewhere in the computer's memory, it's made space for our variable and stored our value in it. So later when we ask the computer to print what's inside that age variable, it prints out 20, the value that we assigned previously. Although we're using an equal sign, try not to think about it the same way you did in high school algebra. In programming, the equal sign means I want to take the value on the right and store it on the variable on the left. It doesn't mean that the two sides are equal to each other. That's important to keep in mind. But now let's look at another example. This time I created a variable named email address, and we've assigned it the following value, jdoe@example.com. If we run this program, we can see that the value of our variable are printed out. So now, even though we've created both of these variables by giving them name, there's something different about the values that we assign to them. Can you spot the difference? So if you thought that the first value, in the first value of age is equal to 20, we're only using numbers. And for the second value over here, we're using symbols and letters inside of it. This is because we want the variables to represent different data types. A data type allows us to put our variable in a particular category so that the computer knows how much space to give us in its memory, and it generally knows how we plan to use our variable later on in the program. So in this example, the 20 is the integer, like what we're already familiar with from math class. In case you've forgotten, an integer is a whole number with no decimal places. And the letters and symbols inside the double quotes is what we call a string because it's made up of a string of characters. In fact, you can check the type of any value or variable in Python by using the type function. So let's take another look. Actually, we have a question over here. Does Python have typecasting? Um, I'm not entirely sure what typecasting is, but if you are talking about having a capitalization in a variable or it being case sensitive, then yes, but I can get back to you on that question a little later today. But for right now, I would like to, yeah, sorry about that. So let's take a look at this example that we have over here by printing out the type of each variable. So if we look at this, age is an int, or short for integer, and the email address is str, short for string. There are many other types of values available in Python as well. We'll get a chance to explore more of them soon. And before you start having flashbacks to high school algebra, I'm not talking about complex mathematical calculations. We use numbers to store a person's high score in a game, someone's bank account information, or even the number of likes on a picture. Python treats numbers in a different way depending on how they're being used, and the difference is largely based on whether it's a whole or fractional one. So let's look at a few examples. Here is a link to a website that lets us code in Python. So I'm going to go ahead and copy and paste this, and you can copy and paste this into your web browser as well. Awesome. So I'm going to go over here. So over here is where we write our code. And once we're done writing our code, we hit run, and it should display a result. So first of all, let's start off easy. Do you remember how to use the Hello World program? First, we would begin by using the print statement, followed by parentheses and quotation marks. So now I'm going to type in hello world. Now I'm going to hit run. So awesome. We were able to display hello world over here on the command line argument. So now that we know that our website is working, let's go ahead and try it out with numbers. So let's say I wanted to find the result of 2 plus 3. I'm going to go type in enter and type in print parentheses, and I'm going to use quotation marks for this one, 2 plus 3. And I want you to notice an important concept over here. If I were to run this, I personally want the answer to be 5 because that's what 2 plus 3 is equal to. But if I were to hit run on this, it's actually going to give us 2 plus 3. And that's because the quotes are wrapped around this exact expression. And like I said previously, computers are quite literal. So if you give them bad instructions or instructions you don't want to, it's going to give you a bad result essentially. So if I were to remove the quotation marks, it's going to give us 5 this time. Awesome. So now let's try something else. Let's do 2 times 3. So if you remember correctly, for multiplication, we would use an asterisk, and that's the representative of a multiplication sign. So 2 times 3 should evaluate to 6, which is demonstrated over here. But what happens if we were to use 2 asterisks? So if we were to do this, it would give us 8. And the reason why it's giving us 8 is because the 2 asterisks represent an exponent. So essentially what it's saying is 2 to the power of 3, or 2 times 2 times 2. Now let's try to print 3 divided by 2. So once again, we do our print statement, and we do 3 divided by 2, which would be 1.5. And as you can see, Python is kind of working like a calculator over here. And lastly, what if we didn't want a decimal point? In that case, we would do 2 slashes, and we would do 3, 2 slashes, 2. And that should give us 1. Awesome. But now let's try to see how Python handles larger numbers. So let's do 45,000 divided by 5. And that should equal to 9,000. So if I were to hit run, I want you to notice what happens over here. We don't get 9,000. And the reason for this is because I used a comma over here. So when using Python, no matter how large your number is, don't use a comma as it's going to mess up the program. So now if I were to remove the comma, we'll get 1,000. Sweet. So So far, we've been only using whole numbers or integers to do our calculations. But in the real world, fractional numbers are a daily part of our lives. So let's say someone were to drop the 75 cents and you only got paid $24. Would you be okay with that? Of course not. The extra 75 cents have value to you. In some programming languages like JavaScript, there's no distinction between numbers with and without decimal places. Whereas in most programming languages, numbers with decimal places are considered special numbers and they're typically called floats. So a float is any number with a decimal point. It's short for a floating point number. It's used for when precision is required, like in the case of our hourly rate. So now let's talk about strings. In programming, whenever we have to deal with text, be it an email address, someone's name, or even an emoji, we use strings. The name comes from the fact that it's a string of characters, one after the other. The characters can be letters, numbers, symbols, and even spaces. They're typically represented by the beginning and ending quotes. Strings can be passed directly through functions, or they can be stored in variables. For example, we can use the print function in Python to display a message on the screen, like hi there. Also, feel free to go ahead and try this on the website that I had sent you. So notice that we have the opening and closing double quotes. These let Python know that it should print out the characters in between the quotes just as we have typed them. So we would also define a variable which contains the same string and we'd get the same result. In fact, with Python, we could use single quotes to create a string as well. But you might be wondering, why would I want to use the double quotes version over the single quotes version? Well, honestly, it depends on the contents of your string. So let's see what happens when we print out the following string that's wrapped in double quotes. She said, double quotes, yeah, let's go tomorrow to him. We would receive an in-text error if we were to run this because Python was confused with the nested double quotes. Instead, we will want to use single quotes to open and close our string, and this way Python knows just what we mean, and the inverse is also true. If we want to use single quotes or an apostrophe inside of our string, like let's get started, then we would use double quotes at the beginning and end. But keep in mind that you don't want to mix single and double quotes together. Something like this print statement, where we have an opening double quote and a closing single quote, will also lead to a syntax error. So when you're first starting out with programming, I would recommend the use of double quotes as your go-to. For this workshop, I'll specifically be using double quotes for strings as it's the most common version that you'll see across languages. So now let's talk about blank spaces. Python doesn't really care about extra empty lines in your programs, just like in most languages. In fact, it's common for developers to add extra empty lines, also known as white space. So you can think of it a bit kind of like paragraphs in a book. So let's take a look at the Google Doc that I had previously sent, and let's copy and paste the practice with spacing section. So I'm going to go over here and copy and paste what I had. Awesome. So as you can see here, everything's really clumped up together. So in order for us to be able to read this a little bit better, let's go ahead and add a little bit more space. So I'm going to go ahead and add a space between lines 2 and 3. And I'm also going to add a space after 5 and 6. So the way I added a space was just by hitting the enter. So as you can see here, this makes it a little bit more to read. And yeah, so although in movies, programmers are often depicted as endlessly typing on the keyboard, they actually spend a lot more time reading and understanding code. That's why we add white space between the different elements of our statement. So now let's go ahead and run this program. So once I hit the run statement, or once I hit the program to run, it says, hi, what's your name? And it's expecting for an answer. So I'm going to go ahead and type in Josh. It's nice to meet you, Josh. Are you enjoying the course? I'm going to say yes. Awesome. So now let's go ahead and add a little bit more white space. I'm going to go ahead and add some over here in line 7. And if I were to run this program once again, we should get the same result. So I'm going to type in Josh. I'm going to type in yes. And as you can see, the extra use of white space over here did not affect the code. However, there are special cases in which the removal of white space will affect your code. For example, with the use of special keywords. So if we look at line number 7 again, if I were to remove the space, And if I were to run this program, it would actually give me an error, a syntax error. And this is because the if statement is a special keyword that needs to have its desired space. So now that we give it its space back, it should work properly once again. Sweet. So don't worry if you didn't understand all the ins and outs of the previous code. Just keep in mind that most of the time, Python is very laid back about whitespace. In fact, you're encouraged to add it wherever it helps to improve readability. But there are circumstances where Python takes whitespace very seriously, and your code will fail if you don't respect the rules. The good thing is that the more you practice, the more you follow the rules without even noticing. Now, comments are notes to your future self and others to describe what your code is doing. Right now, we have small programs. We can keep flow of it all in our heads, but over time, as you continue to grow your programming skills, you'll be writing much longer programs, some even being thousands of lines of code spread over a dozen files. It would be nearly impossible to keep all of that in your head. But by adding comments to your code, you can document the purpose of the different variables, functions, and classes. You can think of them as virtual sticky notes. So let's go back to our code over here. Let's say I wanted to add a comment over here before line 1 that tells me what to do. So I'm going to go ahead and start the comment by using an asterisk. So here we go. And then, or a hash mark, my bad. And then I'm just going to type in greet the user, as that's what we're using. Now, whenever another person comes in, they'll be able to read my comment and see what I'm trying to do over here. And comments can also be used in a different way. We can go over here by line 5, and after our coding line, we can do another comment that says, be nice to the user. So as you can see here, comments are a great way to keep track of what we're doing. And also, it does not affect our code. So once I hit the run button, I can type in my name and click yes, and we get the same result every time. However, comments are also they're also used to block out other code. So for example, let's say I don't want to ask the user if they're enjoying the course anymore. Then in that case, I would go over here to line 6 and use a hash mark. And by using this hash mark, as you can see, it's changing the color of our code, and it's technically no longer there. So Python is going to go ahead and ignore this. So if I were to click run, it's going to ask me, what's my name? I'm going to type in Josh, and it's just going to say, it's nice to meet you, Josh. Awesome. So now I'm going to go back. So, all right, folks. So now it's time for a challenge for y'all. Now that you have an understanding of variable and data types, let's put your knowledge to work. And what your challenge is going to be is to figure out the output. I really want you to try to figure out the output on a sheet of paper. So I want you to go line by line, just as if you were the Python interpreter, and write down what you think the output will be. This is going to help you think like a computer. If you find yourself really struggling, you can always type the code into our website and run it. But I'll give you all around a minute for this. So how did it go? Are y'all ready for the answer? I'm going to work our way through the code line by line to figure out the output. So over here, starting with line number 1, it's our familiar print statement. This is just going to print out challenge 1. And then on the second line, we have a blank. So Python isn't going to do anything over here. And then on the third line, we have a hash mark, which says a message for the user. So it's not going to display anything over here as well. Now on line number 4, we come across our first variable, message, and it states this is going to be tricky. And on the next line, we have another variable called message as well, and it says very tricky. Now, before we move on, we're gonna create a variable called message. But I also want you to notice that this uncapitalized message is not gonna get replaced by this other message. And the reason being is because Python is case sensitive. So it's going to create two distinct variables. Now, on the following line, it's going to print out message. So this message is the uncapitalized version. So it's going to print out, this is going to be very tricky. On the following line, there's no code over here. And then on the next line, there's a hash mark. So Python is just going to ignore this line as well. And then on the next line, we have a new variable called result, which is equivalent to 2 to the power of 3, which is equal to 8. So we're going to go ahead and write that down. So now Python is going to go on to the next line, and it's going to print out 2 asterisk asterisk 3, which is equal to the result being 8. And on the next line, it's going to go ahead and update that result to 2. And the reason why it's updating that result is because it's using the same variable name over here. So we'll have 2 over here. And lastly, it's going to we're going to come across this line which says 5 minus 3. But I want y'all to notice that the hash mark is going to be completely ignored. And on the next line, we have another blank space. And then on the last line, it's going to say challenge complete. So were you able to figure out the output on your own? If so, that's awesome. You're well on your way on mastering the ins and outs of variables and data types. If not, that's okay. It takes a lot of time and practice for most people to really understand how these things work. Now let's talk about conditional code. Have you ever received a note from someone that said, would you like to go out? And the options were yes, no, or maybe? As humans, maybe is often a valid response to a question. It's not quite yes, but it's not exactly no. However, computers are very different. They're very, very absolute. There's only a yes or a no, a true or a false, a 1 or a 0. So any expression that breaks down to either true or false is called a conditional or Boolean expression. For example, is the number 4 equal to 2 times 2? That is true. 4 is equal to 4. But is it greater than 5? No, that would be a false statement. And finally, here's an example that doesn't revolve around numbers. Is my name Steph? Nope, it is Josh. So this would evaluate to false as well. These are what we call Boolean expressions, but as we've learned, computers don't speak our language, so we can't just ask a question directly the way we have it here. And that's where relational operators come into play. We've already worked with several operators, so we've used arithmetic operators like the plus for addition or 2 asterisks for exponents. We've also used the equal sign for the assignment. Relational operators work with 2 operands and they return a value, a true or a false based on the relations to each other, thus the name. The first relational operator will look at this equality operator. Equality operators are represented by a double equal sign, and it's used to evaluate the equality of the operands. So as an example, 4 double equals 2 times 2 will be true. The left side of the operator equals the right side of the operator. Here's another example. We have a variable called name, and we've set it equal to the string Joshua. And now we compare it to the string Steph. The result will be false because the 2 strings are not the same. So now let's go ahead and try some code out ourselves. So we're going to go back into the website that we were using previously, and I'm going to go ahead and delete this. All right, so let's say we wanted to compare if 5 was equal to 4. So I'm going to type in print, and then 5, and then double equal 4. And then I'm going to go ahead and hit run. And as a result, that's going to give us false because 5 does not equal 4. So now, what if we wanted to check the fact that 5 does not equal 4? So in that case, instead of using a double equal sign, I'm going to use the exclamation mark and then an equal sign and then 4. So this is the same as saying 5 does not equal 4. So I'm going to go ahead and hit run, and this should be true, because the truth is that 5 does not equal 4. So now let's check if 5 is greater than 4. 5 is greater than 4. And that should evaluate to true. Sweet. So now you should be getting the hang of relational operators. And now let's create a variable. So let's set a variable called age, and we're going to set it equal to 15. And now we're going to create another variable called age to drive. And we're going to set that equal to 15. So now let's go ahead and compare these two variables. So I'm going to start with the print statement, followed by our parentheses, and then I'm going to type in age, double equals age to drive. And this should be true. But let's say for some reason the law changed and now the age to drive is now 16. So now if I were to hit run over here, it would evaluate to false. Yeah, there we go. Awesome. So now let's talk about conditional code. In the real world, we make decisions based on current conditions all the time. If it's raining outside, I'll take my umbrella. If I'm feeling sleepy, I'll go grab a cup of coffee, and so forth. The most common way for computers to make decisions is by the means of an if statement. We've seen an example of an if statement earlier in this workshop, but let's dive deeper to understand the ins and outs. And if y'all can please give me a moment, as it appears that my computer froze real quick. Let me go ahead and try to refresh this real quick. Give me just a moment, please. Okay, awesome. So an if statement has this general structure. It starts with the word if. That's where it gets its name from. Then it checks some condition. And if that condition is true, then it will do the work that you've placed inside of it. Here's a simple statement in Python. It starts with the word if. Then we have our condition or Boolean expression, 5 less than 6. Next, we have this colon over here. This is part of the syntax or rules of the Python if statement. And on the next line, we have an indented line of code that contains a print statement that will run if our condition is true. This indentation in Python is very important because that's how the interpreter knows which statement belongs to the if. And in fact, we have a name for statements that are grouped together this way in the program. It's called a block. In this example, there's only one statement in our block. But we could easily extend it like this, and now we have two statements in our block. In Python, the block is ended as soon as we have come to a line that is not indented anymore. This new print statement isn't indented. It's not part of the previous if statement. So if we look back at our previous code that we have over here, I'm going to go ahead and highlight the code from the if statement in our Google Docs. Now I'm going to go head back into our coding website. So I'm going to copy and paste that over here. Awesome. So first, we're going to go ahead and run this code again. It's going to ask us, hi, what's your name? I'm going to type in Josh. And then it's going to say, are you enjoying the course? And I'm going to say yes. But what happens if I were to run this code again, and instead of saying yes, I were to say something like dance? Ooh, did you see what happened? I only got the final statement because the line of code inside the if was ignored. The condition answer equals yes evaluated to false. The only thing our statement knows how to handle is the answer of yes, and dance certainly does not equal yes. So now let's run this code again, but let's delete this space over here in line number 9. So once I delete the space and hit run, I'm going to get an error, and this is an indentation error. This is because it goes against the syntax of Python. And in order to fix this, we need to have our block as we previously had talked about. So I'm going to go ahead and add 4 spaces. So 1, 2, 3, 4. Another way of doing this is by hitting the tab button on your keyboard. This is another way of adding those 4 spaces that are required by the syntax. So with if statements, we've discovered a way to add a bit more flexibility and excitement to our programs. But so far, if the condition is false, then we just don't do anything. But typically, we'll want to take some action in this case as well. This is done with the if-else statement. It looks very similar to our normal if statement, except that it has the else keyword along with a colon followed by a code block. In programming, this is called the else clause because you never find it without an accompanying if statement. Just like in English, if I said every night before I go eat dinner and that's it, that would be an incomplete thought. It's just a clause. I'd have to add something like every night before I go eat dinner, I go for a run. Now the thought is complete. Similarly, we don't use the else clause without an if statement. So let's look at an example. If 5 is greater than 6, then we're going to print out 5 is greater than 6. Weird. Otherwise, if it's not true that 5 is greater than 6, then we're going to print out 5 is not greater than 6. When this code is run, first the condition of the if statement will be checked. And since 5 is not greater than 6, it's going to evaluate to false. Since the condition is false, it's going to skip over the if code block and drop down to the else clause. The result will be the output of the else print statement, 5 is not greater than 6. So now I want to go ahead into our website once again, and let's go ahead and copy the paste of if statements part 2. And it's the one with the cacti. So over here, once you copy and paste this, we have this new code. And it starts with a variable called plant, and we have set it equal to cacti. So if the variable plant is equal to cacti, and if that's true, it's going to print plant does not need a lot of water. However, if it's false, it's going to print plant loves water. Thanks. So let's go ahead and run this and see what happens. And as expected, it printed out cacti don't need a lot of water. But what happens if we were to change this to roses? So now plant is not going to equal cacti. Thus, it's going to go ahead and skip this code, and it's going to go directly to the else statement. So we're going to go hit run. And that's exactly what happened. Roses love water. Thanks. All right. So with if-else statements, we will always execute one of the code blocks depending on the result on the condition test. This makes it perfect so when we need some action to take place in our program. By now, you should be pretty familiar with the conditionals in Python. So in Python, we start with an if followed by our condition, then we end the condition with a colon. And then on the next line, we indent the block of code that we want executed. And the else is very similar, except there's no condition to check. In Java programming language, the if-else statement has a slightly different syntax. Remember that syntax is just the same thing as saying rules for how a programming language expects its code to be written. After the if keyword, there's a set of closing and opening parentheses, and inside these parentheses is where you put the condition that you want to be tested. And instead of a colon after the condition, a pair of opening and closing curly braces are used to denote the code block for the if. And the same thing is true for the else clause. Now, although it's customary to indent the statements in the code blocks, it's not a requirement the way it is for Python. So let's look at one final example with the Ruby programming language. Ruby is known for its ease of use and flexibility, but just like other languages, the structure of the if-else statement is the same, but the syntax differs. With Ruby, there are no parentheses or colon to separate the condition. Even the else clause just stands on a line all alone. The one thing that's more noticeably different is the addition of the end keyword over here. This is how Ruby notes that it's done with the if-else statement, not based on the indentation or curly brace, just like Python and Java. The cool thing about learning the basics of computer programming is that once you grasp the structure of the core statements and principles, you can more readily recognize them across all languages. Now, let's talk about modular code. So functions make our programs easier to read and write and debug. A function is a block of code packed together with a name. So they're a core feature of all programming languages, yet depending on the language, they may be called subroutines, methods, or some other name. But it's all referring to the same thing, a way to break up your code. In this presentation, we'll call them functions. In fact, you've already used a few functions like the print to show something on the screen and input to get a response from the user. There are hundreds of other functions in Python that we've yet to explore. One key benefit of functions is that they always help us to avoid writing the same lines of code again and again. You can think of it like this, and I really like The Office. And if I wanted to teach you my favorite dance move, the scarring, I'd have to walk you through the steps one by one. However, we're not in person, so I'm not going to go dance right now, but these are the steps. So first, you would jump to the right and shake a hand, and then you would jump to the left and shake that hand, meet new friends, tie some yarn, and that's how you do the scarring. And that's it. Now you know how to do the scarring, and then the next time I say, let's do the scarring, you know exactly what to do. I don't have to walk you through the steps each time, and it's the same way with functions. We teach the computer how to do something one time, and from then on out, we just call the function by its name, and the work gets done. No need to repeat ourselves. So let's imagine this is our scarring code. I'm going to go ahead and share my screen once again, and let's go look at the Google Doc, and we'll copy and paste the scarring onto the website. So over here, I have the scarring. So let's say I wanted to go ahead and print this out 4 times. So let's do it manually first. I'll copy and paste this 3 more times. And once I hit run, it should display our steps. Awesome. But notice that there's a bug in our code. On line number 2, or line number 8, or line number 4 actually, it says jump to the left and shake that band. It's supposed to say hand. Now, imagine if I had thousands of lines of code like this. I would have to independently come to every single line and replace it one by one. And this is the beauty of functions. Whenever something like this happens, you only have to do it once. So in order to start a function, I'm going to go over here on line number 3, and I'm going to start with def. That is just the syntax of starting your own function. And I'm going to call this function scarring. And then due to its syntax, I'm going to add parentheses and a colon. Then I'm going to go ahead and highlight lines 4 to 6, and I'm going to hit the tab button. That's the required indentation that we need. And now I'm going to go ahead and delete all of this stuff, hit backspace, and we should be good. But one last thing is that I'll replace band with hand once again. And I'm going to go ahead and run this. And yikes, we only get the scarring as the title. So remember what I said earlier, computers are quite literal. Thus, in order for this function to work, you need to call it out. So here on line number 8, I'm going to go ahead and type in scarring, followed by its parentheses. I'm going to hit run. And awesome, it printed out the instructions. But let's say I wanted to do this 4 more times, or 3 more times. All I have to do is just type in the function, and then hit run, and then it prints out the steps, which is just what we wanted. Sweet. So now I want to talk about parameters, which is going to be the last concept for today. So here's a little story. So growing up, my siblings and I loved going to the car wash, and depending on how much money my parents were willing to pay, we would have a different experience each time. For $6, we would get the most basic car wash with the white foam, 1 rinse, and a drip dry. But if my parents were willing to spend $12, then we would get the tricolor foam, 2 rinses, and a blow dry. That was quite the adventure for 7-year-old me. But just like the car wash, in programming, we often want to provide different outputs to our users based on some input. And functions allow us to do that. So let's run some code to simulate this experience. So let me go over here, and we'll go ahead and look at the Google Docs once again. And we'll copy the last section, which I called drip drip. So I'm just going to go ahead and delete this, copy and paste this over here. And as a result, we have the following code. So we have the function defined in line number 1, a wash car, and then we have our open and close parentheses inside. We have our car wash steps over here, and this one is the one for the $12 or the premium wash, and this one would be for the basic wash. So let's go ahead and call this function on line number 10. So wash car. Awesome. So now I'm going to go ahead and hit run. And notice what happened. it actually went ahead and printed out all of the steps. But what if I wanted to separate the steps based on the amount paid? So for that, we're going to go ahead and create an if statement. So this if statement is going to allow us to choose between the two different code paths. So if, and I'm going to create a variable called amount paid. If amount paid is equal to 12, followed by a colon, it's going to print out the following steps. So once again, I'm going to go ahead and highlight this code and hit the tab button as the proper use for the syntax. And now on line number 7, I'm going to do the same thing, but instead of $12, I'm going to go ahead and type in 6. However, because we are comparing these lines of code, we're going to have to use 2 equal signs. And this is a conditional. So if amount paid is equal to 12, we'll print this out. Now, if it's equal to 6, we're going to go ahead and print this out. So we're going to go ahead and hit run and see what happens. So, oh, my bad. As you can see here, I made a silly mistake and I forgot to use the tab. And I was able to figure this out because it tells us right here, tab error, inconsistent use of tabs and spaces in indentation. So now this problem should be fixed. So now we're going to go hit run once again. And oh, if we look over here, it says name error. Name amount paid is not defined. So whenever we have a function and we create a variable over here, we need to set up the parameters within the function. So in order for the wash car function to know that amount paid is a variable that exists, we're going to have to type in amount paid over here. So now if we run this code, wash car, our function knows that our parameter exists. So awesome. We're going to go ahead and run this one more time. And yikes, now it's saying that wash car is missing one required positional argument. So essentially what this means is that whenever we call our function, it doesn't have any value within the parentheses. So if I were to want to have the premium car wash, we would have to write 12 over here at the bottom. So once we run this code, it's going to identify the 12 and it's going to compare it to amount paid, or it's going to store it in amount paid, and then it's going to go ahead and compare it inside of here. So if we hit run, we now get our premium car wash steps. So wash with tricolor foam, rinse twice, and blow dry. And now you can go ahead and try this with 6 as well. And if we run this, it should repeat the process for the most basic car wash. So yeah. So with this presentation, I hope that today you were able to learn a few more skills in Python. So I really hope that this tutorial was very helpful for you. And for those who already knew the concepts, I hope that the analogies and real life examples help provide a new perspective for you. So before we leave, I need to give out a huge shout out to LinkedIn Learn. LinkedIn Learn is not one of our sponsors, but a lot of the material that I used today was provided by them. And it's an absolute free resource that we as UTSA students have and we can utilize to learn. So if you want to continue your coding path experience, I would highly recommend for y'all to use LinkedIn Learn. As one, it's given to us as UTSA students, and 2, it's free. And with that being stated, if you do have any comments or questions, you can always reach out to me on our Discord for ACM. Over here, I sent out an invitation. So if you haven't joined our Discord yet, you can go ahead and join us and get in touch with us. But you can also follow us on social media at ACM-W And just as a friendly reminder, next meeting will be our ACM open house. This will be in person on Wednesday. So if you want more information on this, I highly encourage y'all to visit our Discord link. But with that being stated, I'm going to conclude the presentation, and I seriously thank y'all for coming. So I hope to see y'all soon. Bye.